Oh, all right. Let's see. Currently no viewers, but that is okay. Because based on some of the comments I was seeing, it appears that we want to know how to build Pong and run it on Android using C++. So I am going to walk us through that and my process, especially as a C++ professional, how I want to go about doing that. That's going to involve a Git repository, some software pipelines, CI/CD pipelines to make sure that our code will compile on all these platforms. And then by the end of all of this, we should have Pong running on the phone. Let's get started. I think step one is going to be to actually create our repo. So I'm calling this Pong game Echo just to be fancy and cool about it. So I am going to come into my repository here and create a new repo inside GitHub. I strongly recommend, even if you're making a toy project, put it in a repository somewhere. You never know when you might lose power, you might spill something on your computer, a file gets corrupted, your hard drive fails. Any of these things can happen and then cause you to lose all of your progress. So it's one of the first things I do now is I make a repo. So I'm going to call this Awin Echo. Awin is the GameWork application frame. GameWork. Awin is the game engine or application framework that I have been building while I stream, and I try to grow and become better at streaming. Therefore, I am going to name this Awin Echo as kind of a derivative from my Awin framework, since a lot of the work that I have done to support cross-platform development on desktop, Android, web has been through this Awin framework. I'm calling it Echo because Pong is kind of like the ball is getting echoed back and forth. And I didn't want to call it Pong, so Echo. This repository, if I can spell it right, this repository contains a demonstration on building Pong for multiple platforms using C++. We're going to make this public. We will have a README. The git ignore we will initialize with common C++ ignore files, and then we will make this an MIT license for anyone to grab, modify, and tinker with. So I'll go ahead and create my repository. So from here, we have our repo. I am just going to clone it using VS Code from GitHub. Echo. And then I want to store it in a local directory. Open it. We now have Awin Echo. And I'm going to go ahead and grab that icon, the banner file for this repo. Let's rename it banner. Paste it in here. Cool. All right, we have a banner. So now that I have a repo and I know I want to use C++, where in the world do we even begin? I personally like to try and get a simple main.cpp application up and running. And since this repo isn't going to be using any libraries, it's just going to be a single executable that we will load on desktops, Android, and web platforms. We'll just create a simple app folder, which will contain our Allwin Echo. We know we're going to need a main.cpp. I always name my source file that's going to be the entry point to the application, main. That way you are always consistent with how you build your projects. Anyone else who comes to read your repo will understand exactly where your entry point is as well. I really do not like using different naming conventions for main.cpp. That should be a fairly standard way of naming your executables source files. Now, the other portion to this is cross-platform compatibility. So we're going to need to be able to compile this code for Linux, Windows, Android, and web. And one of the more standardized ways of doing that is using CMake. CMake is a cross-platform solution for generating project files for your source code on these different platforms. So Linux might be a make file, Windows might be a Visual Studio.solution file, and CMake provides a common way of doing that. CMake requires a cmakelist.txt file. We also need a cmakelist.txt file at the source at your root of your repository. That way, when we actually run CMake, we can use this root file to kind of set up global project configuration settings and also point to where the application is. And one of the first things we do here is set up the minimum requirement, which this could honestly be the smallest version of the feature set you're going to use. I typically like to point it at whichever CMake version I am using in my toolchain, and I believe we are going to be using like CMake 3.1, something like that. If I need to, I'll update it. We're going to name this project Project Echo. We're going to add a subdirectory to point to our app folder. And that is all we need for the second, because we still need to get other CMake files and stuff stood up. The other file we're going to be using is cmakepresets.json. Cmakepresets.json is another way of providing inputs to the CMake executable or the CMake project. More legacy way of doing this would be using the -d inputs. CMake presets kind of covers that for us. I think I want a CMake folder where I will put custom presets. Now, I've already written all of this in my Allwin framework, so I am mostly going to be copying and pasting from there, maybe with a reduced set of configuration options, since this is going to be a simpler project. So inside CMake, we're going to have our preset folder. This is where we're going to stick all of our compiler settings for the different platforms we want to support. So therefore, I'm going to have a compiler folder. And inside the compiler folder, we know we want to support Android, web, Windows, Linux. That means I'm going to define a preset for the Android NDK, the native development kit. The Android NDK is what contains the compiler toolchain to build your binaries for Android compatible platforms. Without this, we won't be able to build for Android. I'm also going to do GCC. GCC gets us your standard GNU compiler toolchain for Linux. And then we're also going to do MSVC. So that's going to be your Microsoft Visual C compilers, cl.exe, that kind of thing. That will give us the ability to compile on Windows. And then the last compiler we're going to want to support is EMCC, also known as Emscripten, which brings in the compiler toolchain for building WebAssembly. All right, so here comes the copy and paste job. So on Android NDK, I'm going to copy and paste this. I am essentially defining some compiler flags to enforce strict adherence to the C++ language. It also treats all warnings as errors. I am, from a professional standpoint, never allow warnings to propagate your project. I always make sure that I address any warnings that pop up as they show up. Let's grab the Emscripten compiler flags here. And you'll notice these toolchain files that these compilers are loading in, they are pulling in additional settings to get these compilers up and running and pull in their environments, that kind of thing. We'll grab GCC, and then we'll grab MSVC. All right, so now that we have our presets for our compilers, the next thing we're going to need to define is the platform we are going to build on. So that's where these host presets are going to come into play, except I got to actually put it in the right location. Again, copying and pasting. We're just going to do Windows and Linux. I'm not going to pull in the entire set. If you want to see how everything is done, check out the Awin framework. It will have more options. Let's see. We want to compile on Linux. And we want to compile on Windows. So even though we're going to be building for web and Android, we're doing that on a Windows machine. That's where these host settings are coming into play. They're basically saying, hey, when using a CMake preset, if you're on Windows, allow this preset. Make this preset available in your CMake list of presets. If we weren't on Windows, then this preset would get shut off and you'd have to go use a different one. Now we want to define our target platform. So if we are building on Windows or Linux, our target is going to be Windows, Linux, Android, web. So we're going to create an Android target, and I'm specifying ARM here because most Android platforms are using ARM processors. And in this definition, I specify the ABI I want to use. So their older Android platforms use, I think, like a version 7 chip. For newer phones, especially the phone I'll be demoing this on, it uses a version 8 chip. And then we'll also be targeting the Android version 35 platform to do this with. And then for web, we want to target the WebAssembly, which is going to be WASM32 emscripten.json platform. This is what we're compiling to and what will generate our HTML, WebAssembly, and JavaScript files. And you'll also see in here that I define a HTML suffix. That's going to help us ensure that when we compile our executable, it generates a HTML file that we can load in a browser. We'll grab our Linux target here. pretty straightforward. We're just saying, hey, compile on Linux. And then the same for Windows. We're going to say compile on Windows. Now, there is an additional flag that I haven't really been talking about yet, and that is the VC package host and VC package target triplets. This is a Microsoft maintained package manager for C++. And these CMake variables that we're defining is telling that package manager, hey, build any dependencies I need statically. So if it isn't clear yet, this project is going to use, and Awin as well, uses VC package as its core package manager. So we're not going to be pulling in custom or open source libraries manually ourselves, compiling them, fighting with compiler flags, and figuring out how to link these libraries. We're going to use VC package to automatically handle all of that for us, and then the only thing we have to do is use CMake find package and then link it. All right, so once the targets are defined, we need to set up our configuration presets. So I'm going to create a config folder here. And this is going to have a little bit more general configuration. So if we want to build our project in debug or release, we're going to do so like this. Pretty simple. We're just saying, hey, when we use this debug preset, we're going to make sure the CMake build type is set to debug, which CMake will then tell compilers to build with no optimizations. And we also want to define a preset for release. Then we want a preset for the location to build our code. So when we build our code, we really do not want the code to end up in our source tree. So the root level here of our project, you don't want to see a bunch of temporary object files, auto-generated CMake files, Ninja tool chain files, and everything else in between. You want to make sure all of that is contained within a single folder so you can guarantee a single source of truth in case you ever need to clean your project. It's as easy as delete the build directory. So that's what we're going to define here. And to support multiple presets, we're using the preset name. That way we can have a debug preset, a release preset, Windows, Linux, Android, web. All of that can live under that single build folder. We're also going to be making use of Ninja for this project. So Ninja is a generator and make tool, essentially. So instead of using make files, we're going to use Ninja build tool on both Linux and Windows. I already have it installed on my Windows machine manually. And then on Linux, it should be as easy as apt install Ninja build. But we're going to make sure we have a preset that tells CMake to use that. And then if you don't have that tool installed, then CMake will yell at you. Then last but not least, we will define our VC package inclusion. So this is where we will tell CMake to pull in the VC package toolchain so that we can set our project up to use the VC package project manager or package manager. And I do want to make sure I prefix all of this with config. And that is so I can more easily sort through this when we start defining the actual presets. So far all of these component presets are being used or will be used to define the CMake preset itself. So if I want to build on Linux for Android in debug, that's where these platform presets are going to come into play. So I want to define a platform called Windows. And in Windows, I will define all the different component combinations that I need to build a project. So we're not for this example, we're not pulling in Visual Studio. I'm keeping this kind of more command line friendly. Let's auto complete fix all of this, since I gave everything a config preset. And then that looks good. So this is basically saying, hey, if you pick me, then you are going to define a debug preset, which pulls in all those CMake variables we defined in all of these different components. I'm going to do the same thing for Linux. We have our Linux presets. Now, I'm not pulling in Clang for this example, so I'm actually going to remove these since they aren't even going to work. I wanted to keep this project a little simpler, and we will be using Clang for Android anyway, so it's not really a miss if we don't have Clang on Linux. Maybe I'll put it in later once we get into the CI/CD portion of this. Okay, that looks good. And then we also need to define an Android platform. Get our Android platform going here. So just like the other platforms, we're saying, hey, on Linux, build using the Clang compiler for ARM Android 64. But we can also do this on Windows. Windows Clang ARM 64 Android. All the real dependency comes into play is getting that Android Studio or Android SDK and NDK set up for your environment, which I'll cover later as well. My screen's getting dark. Let me fix that real quick. Let's see here. Okay. All right, so that's the Android preset, and I think we also need the WebAssembly preset. So that's going to be our WASM. And this will define the configuration needed to build this project for WebAssembly. And all the components necessary to do it. So we've covered debug and release. Cool. All right. Once the preset components are defined, the next thing we need to do is actually tell CMake those presets exist. So that's where the CMake presets.json file at the root location of your project is going to exist. And in here, since we've already handled defining the presets, we just need to include them. So that looks something like this, minus max, since I won't be covering that for this demonstration. So by including this, we tell CMake, here's our available presets, except I've got some errors that I need to fix. vcpackage.json cannot be found. Why is that? Because, oh, I know why. So where is it telling me? Can't be found in windows.json. So if we go into these platforms, these guys live in config folders now, so it needs to be more like you go up a level, config / yep. Well, that's not right. This needs to be more like let's insert. I think this becomes like target. No, my AI is trying to help and it's not. Being kind of a jerk. Okay, so, and then I think this is a config as well. No. The compiler isn't in a config folder. I think everything else is good here, so we can sort this. MSVC compiler, that looks good. Let's go ahead and sort these while I'm at it. That shouldn't be called config. That's a target. That shouldn't be called config. That's a host. That shouldn't be called config. That's a compiler. So let's sort this one last time. Then see if we can get AI to do its job here. Can you fix this for me? No, it's not going to. Okay. Oh, wait, now it is. There we go. Let's sort this. Cool. That looks good. All right, so that's resolved. Now, if I had to guess, there's other platforms, Wasm, Linux, and Android. Yep. Okay. So on Linux, let's see if AI is caught up with what needs fixed here. That looks good. This does not look good. We can actually, let's see, release. That's config. Yeah, see, it's trying to do everything and it can't. There we go. I'm sure if I had AI instructions in this repo, it'd probably do a better job. AI does take a little bit of configuration management if you want to get the best out of it, get the best results from it. Let's see if this will config. Yes. Yes. Okay, it's getting smarter. There we go. All right, cool. So then let's sort that. I like to keep, especially when it comes to like configuration. If it's a list of things, I like to keep it sorted. Just makes it a little easier to read. Anything that makes it easier for a developer to parse, so they don't have to think too hard. We've got plenty of other things to think about instead of worrying about like where something is. Let's config. Debug's a config. Ninja release VC packages a config. All right. Yep. The AI is smartening up. That's good. Cool. Let's sort. Okay. And then is that everything? What am I missing one? I think I'm missing Android. Yeah, I'm missing Android. All right. Config. Config. This is so nice. Once it knows what to do. Let's see. Sort. I'm thinking this might become my first YouTube video, even though I'm doing a terrible job of narration. So maybe I'll do a voiceover, and then this part will be one of those like fast forward parts. I don't know. We'll see. Or I'll scrap the whole thing. Okay, so we're almost there. Linux and Android. It can't find the compiler Android ndk.json in Android. Compiler Android ndk. Compiler Android ndk. So I'm not sure what's going on there. I'm hoping I just need to do a refresh. Actually, let's just do that now. Reload the window. I'm reloading the window because the way VS Code works with these CMake presets is it has to parse the files, and if it fails to reload what it's parsed, then you could end up with errors that aren't actually errors. Okay, so compiler claim can't be found. That's true. I did not pull that in because I didn't want to overcomplicate this project. But now that I am thinking about it, I probably do want to add it, because we are going to need this for CI/CD solutions, and I do want to go over that and why we might want to use that. So let me grab the Clang compiler preset here with its own compiler flags. And that should take care of that. It can't find android-ndk.json. What do we think is going on here? Android is it because I didn't include it in the android.json file? Platform Android compiler android-ndk.json. Oh, I fear I might have a typo here or something, and I'm not seeing it. Oh, there's a white dot, which means I didn't save the file. Yep. I'm a professional. All right. Save, yes. All right. So the CMake presets are set up, I believe. That means we should, in theory, be able to pick and choose which platform we want to build on and build for, assuming, of course, our code is checked out on that platform. Now I want to just do a simple hello world to start with. So we can do new in C++, print, and we will do print standard print. We'll do a print line. Hello world. Except I think this application is called Echo, so we'll say hello Echo. And that should be good enough. So we'll need to see if that will compile, but I'm assuming it won't, because in our CMake project here, we say add subdirectory app, but when I go into the app folder, do we have CMake defined? We don't. So this needs to become project Awin Echo. We're going to add an executable and give it a name, which is going to be our project name. And then we're going to give it the source files to compile for this target. It's private. It's not going to become part of any other project via linkage or inclusion. The file is obviously called main.cpp. And then I think, and we also want to say that we're going to use the C++ 23 standard. We want to enforce the standard. We want to not have any extensions. And in newer CMake versions, we want to turn, I think it's scan for module. I gotta see what it's actually called. I forget. CMake scan for modules. CXX scan for modules. We want to turn this off because it can get in the way if we're not using modules. Is that what it is? Is it just CXX scan for modules? Let's turn that off as well, since we're not going to use C++ 20 modules in this project. All right. Let's see if this compiles. So like I said, we need to reload VS Code so that it can parse the CMake presets that we've just edited. And if it parses, we'll see it parse through all the files here. And then on the left, if we have the CMake tool extension installed, which I already do, CMake Tools by Microsoft, on the left here should be a CMake icon. And there will be a configure section, and in that configure section, an edit box. If you click on the edit box, you should now see the presets that we have defined. I don't want to do Android yet because that's going to take a little bit more work, so we're just trying to make sure our application compiles on Windows. So I will select Windows, MSEC, and I'll do a release build, an optimized build, to get the utmost performance out of printing a line. And then we will hit configure, which is, once this is selected, we can hit configure. And then in the terminal here, we'll see that our project failed. Now, the project failed because we told CMake we wanted to use VC Package, the package manager, but we never actually went out and got VC Package. VC Package is in GitHub, so if we actually took a look, we could go to github.com/Microsoft/VC Package. You got to make sure you spell it correctly. Well, I can't spell it all. Microsoft. And in this repo is the package manager. This is where everything you need to essentially pull in any dependency you might possibly want. You could clone it from here, but in our case, I want to actually ensure that this project uses a specific snapshot in time of VC package. And the best way to do that is to use a what's called a git submodule. So actually in my VS Code terminal here, I will do a git submodule add, and then I will specify the link to the VC package repo. And this should clone it to our project. Once that is done, I actually want to use a specific tag from VC package because it helps guarantee that you'll get the most stability out of all the dependencies in VC package. So what I like to do is using the git graph extension from VS Code, VS Code, I will go into my git list here where I just cloned VC package and navigate to the VC package repo and be able to click on the git graph. You could also do this on the command line, but we're looking to check out a specific tag, the most recent tag. So by just scrolling through the git history, I see that this tag was the most recent, so I will check it out. I'm okay if we check it out to a detached head because we will be saving the hash of this commit as part of the submodule. So once that's checked out, I can stage all my changes here, hit the plus sign in VS Code, and then get back to my project. So all of this was because our CMake configure wasn't working. So once we have VC package cloned, I should be able to go back to my CMake extension here, hit this configure button again, and we might see some configuration happening. Okay, so now we successfully configured. I should be able to hit the build all projects button, compile, and it compiled. To see if it works, let's navigate to the build folder, and our preset is x64 Windows Release. And we have to actually find where it was built, and I think CMake will default it to your application folder. Yeah, your app folder, since that's the location of the source code called Alwyn Echo, and we get hello Echo. Perfect. All right. So now we have a project that compiles on Windows. The next step I want to do is make sure this project compiles on Linux. Now, I'm on a Windows system, but Microsoft has implemented a solution for Linux development called Windows Subsystem for Linux, which is kind of a lightweight virtual machine. So we're going to make use of that in addition to a solution called Docker to run a self-contained environment with all of our development tools for Linux. I don't want to go into too much detail on how all that works because that could be its own day-long video. So I'm just going to get this set up pretty quickly and then hop into the Linux environment and make sure it has all the tools we need, and then we'll compile and verify that hello echo still occurs. And before I do that, let's go ahead and commit my current changes to make sure we save a good state. Hello, Echo, working on Windows. Commit. In our ignore file, we also need to make sure we ignore our build folder so that we don't accidentally commit all of our temporary files. Let's commit that as well. Ignore temporary build files. Okay, let's get that pushed up. All right, so for Linux, we're going to make use of something called dev containers. The way you do that in VS Code is you create a .dev container folder. You create a dev container.json file, and then we also want to create a Docker file, which is what we are going to use to define our Linux environment. And again, all of this exists in the Awin framework. So I'm going to try and implement a simplified version of this for this project so that it's a little easier to parse and understand. So step one, we want to use Ubuntu 25.10 so we get access to newer compilers and tools. And then I'll do some copying and pasting here. Except I don't think we need so many vertical installation lines here. But this is basically telling our Linux environment to install a bunch of tools, common tools that we're going to need for software development in general. So you'll see there's Git, CMake, Ninja. All of that is necessary in order to build this project. Since we're cloning VC package, we are using CMake to configure our project, and we're using Ninja to help us generate and build our project. Now, I'm also going to add curl here because I know VC package needs curl to download dependencies. And then we also want to make sure we install the GCC and Clang compilers. So that's going to look something like, let me actually pull up an example from another repo I did. Because sometimes with Ubuntu, it requires setting up update alternatives. So I want to make sure I do this correctly. Going into another repo I work in. Here we go. Okay, it might be as simple as just installing it. Maybe I don't need to do the update alternatives. All right, so this will give us GCC and Clang. And then that might be all we need, at least for Hello Awin, or Hello Echo. But once we actually want to get graphics going, we might have to add more to this. Okay, so once we define our Docker container, we need to define our dev container here to tell VS Code to use the Docker file. Let me grab my dev container config from Awin. These are just some useful extensions that you can feed the dev container to, so when you reload into this Linux environment, VS Code can make sure these extensions are installed for you. All right, so now that we have our dev container defined, let's try and open it and see what happens. I click in the bottom left corner of VS Code to get this pop-up, and then there should be a reopen in container option that you can click. If all goes well, we'll see a pop-up in the bottom right here that we can click on and see the output of the container being built. Protein cookie break. I imagine this is a part of the video where I would fast forward through. If I even show it at all. Don't know how much my target audience is expected to know versus how much they're trying to learn, because I imagine this is a lot at once. I also don't know who my target audience is yet, because I don't really have one. I think I've had one person come say hi since I've started doing this. So we'll see. It'll be edited in post. Maybe I can make this approachable. Okay, I think we are ready to go. So what we can do is try and configure GCC release and see what happens. Configure, generate, done. So just like on the Windows side, we hit build. I need to create a new terminal here. So it built. So in our terminal, probably need to go to a similar location like Windows, where we go into build, except specify Linux as our preset. App Awin Echo. Run it, and we get Hello Echo. Perfect. Everything's working so far. So let's hop back over to Windows by closing or reopening folder to local. So now I'm back on Windows doing development. I'm going to go ahead and commit the dev container since I know that works. Something else I'm going to do real quick is create a .vs code folder and define some settings. Because one thing VS Code likes to do is every time you make a change or switch between windows, it's going to reconfigure your project even if you don't need it reconfigured. I like to be in control of that myself. I don't like VS Code doing that for me. So I'm going to tell it not to. So that's CMake on, or let's see, figure on open, I think. We'll set that to false. And we'll probably also say cmake configure on edit to false. That way I can decide when I'm ready to configure the project. And then the other thing I really like is when the language supports it in VS Code, I would like to format my files so that I don't have to manually make sure my files are getting formatted whenever I save. So I'm going to set that to true. And I'm going to commit that as well. All right, committing our changes. Hello Echo is now working on Linux, so let's save our state. Oh, making a mess. All right. So next step. Can we get this compiling for Android? This is where it gets a little more complex, I think. It actually gets pretty complex. So one of the packages we're going to be using is SDL3, which I think is like simple direct media layer, something like that. And we'll use a VC package to pull that library in. But SDL3 will handle creating a desktop window, an Android window, a WebAssembly window, which technically is just your browser. And then we'll use that to also draw graphics to the window. So that's what's going to give us our Pong paddles, text, that kind of thing. So let's go ahead and get that pulled in and built because that's going to take a second. And we do that by creating a VC package, vcpackage.json file. And I'm going to go ahead and copy straight from the Awin framework again. That configuration. I'm just going to leave this the same. Doesn't really affect VC package. What we really want is SDL3. So with that in play, if we go to CMake and hit configure again, it should start to check out all the dependencies needed to, not check out, but download all the dependencies needed to build SDL3, build them, and then build SDL3. And then in the CMake output, it should tell you how to link against it. And that is exactly what happened. So we VC package pulled down some CMake files, and then it compiled SDL3, and then it says, hey, in your CMake project, use find package SDL3 config required target link library. So we're going to go ahead and copy that. Go to our app in our CMake file here, paste it, get rid of the log lines. Then AI autocomplete for us, cool. So then I like to do this. For consistency's sake, make it nice and formatted. All right, so now we have told CMake to link SDL3 to our project, so we'll hit compile again. And it should compile, and we can verify that everything still runs. It does, good. So now we need to get Pong drawn. I'm not going to go through the steps of writing Pong from scratch. So I'm going to copy and paste a solution I already have. And then we can go over some of what the code is doing so everyone else at least has a gist of what is happening. Actually, Maybe it would be worthwhile implementing my own Pong so we can see the project build up from scratch using SDL3. Maybe that's what I'll do. That might be a little nicer. Okay. So step one then would actually be getting a window to render, which means we actually need to include SDL to do that. So since we have already used VC package to link against SDL, that's going to automatically pull in where the header files are located. So we don't have to worry about that. We just have to include it and use it. So I'm going to include, and it looks like this is already set up to autocomplete, SDL. Okay. Another issue I just ran into. So I have format on save turned on. So when I hit save, it moves my code all to one line. I'm not a fan of that. I actually have a certain way I like to format my C++ code. And there's a way to enforce it. And I do that using something called Clang format. I actually already have the extension installed. And on Windows, I have Visual Studio installed, which also comes with Clang format. So I have all that set up in my environment. But what I don't have is a .clang format file to tell the Clang format extension how to actually format my code. So I'm going to go grab that file real quick. Once again, that exists in the All-In framework at GitHub/Funded Software LLC. So I'm going to go ahead and copy and paste from there. This Clang format file has been crafted over probably a decade of basically how I want to format my code. Oops, I did that wrong. Clang format. Okay, so this will tell Clang format how to actually format your code. So now when I hit save, okay, now we're back to something a little more readable. All right, so where were we? We were including SDL3, and we need to create a window. So I want to, and I'm using SDL documentation. I don't know all of this off the top of my head. You know, even as a C++ professional, you're not expected to know how to do everything and use every library. You got to use documentation. Or if you have AI, then just use AI to generate it for you. It is more recently it's gotten pretty good at giving you example code for API usage. So I want to tell SDL to initialize the video drivers. And I believe this returns an error code. Doesn't it? And I think in SDL3 it actually returns true or false. So we might do something like if SDL init, if not SDL init, then we want to return an exit failure. Only at the end do we return an exit success, which are macros defined with 0 and 1 typically. Oop. The other thing we actually need to do is put a try-catch block around main. And this is kind of a catch-all. I'm not going to go into too much detail about it now. I'm just doing that as a the general way of doing things. Let's see, SDL init. And then we want to create the window. So if we get past this check, we are now allowed to create our window. So let's do a const auto. The window will be a pointer. SDL create window. Oh, and it's auto completing for us. Now I don't want to use hard-coded values like this, so I think at a minimum, I want to define some constants. AI may or may not do this for us. So let's do like const expert auto. Sure. We'll do a title, an X, a Y, a width, and a height. Except I like to do, I mean, these days, I think 1280 by 720 is a very, very usable size for most displays. All right, so we create the window. What else do we need? I don't know if we need the renderer yet. We just need to put this in a loop. We do need to handle events so that the window knows to be able to like move around, resize, close, that kind of thing. And I think SDL, if I recall, has an event loop. Yep, it does. Okay. So we might do something like while not window. And I think, does SDL have something like SDL window should close? It's been so long. SDL window should close. Yeah, while not window should. Oh, look at this. The AI auto completed for me. So basically, this will loop over the events. Pull event will populate our event field for SDL. If we get the quit event, which is closing the window, then we're going to destroy the window and quit. Except that's not quite how I want to do this. I would like to destroy the window towards the end of the application. So here, we'll just say destroy the window, quit. And instead of waiting for the window to close, we can say auto running equals true. While the application is running, and then if we get quit, we just say running is false, which will break us out of this loop, and then we destroy the window and quit as part of the cleanup. So let's see if that was enough. Let's compile. Compile errors. SDL window shown undeclared identifier. I don't think this should be like window resizable, I think. SDL quit renamed. SDL event quit undeclared identifier. Window cannot be used before it is initialized. We might be running into an issue with the SDL API because I don't remember the API. What's going on here? SDL init video. SDL create window. Create window takes a title, a width, and a height. So I don't know. Maybe that's wrong. Title, a width, and a height. Let's see if that compiles. So it doesn't like SDL quit. It might be like SDL event quit. Now it doesn't like SDL destroy window. Maybe because I made it const. Yeah, we can kind of see the error here. Which makes sense, because destroy window probably has to modify the pointer. And now we have unused positional variables, so let's get rid of that. We'll compile it. All right, it compiled. Let's see if our application creates a window. Ladies and gentlemen, we've got a window. Awin Echo. All right, so that's step one. Get a window running. All right, let's go ahead and commit that since we know it works. Working window with SDL3 on Windows. Now we can make sure it works on Linux. Now, if you recall, I made this Linux Docker file with some basic utilities and compilers. SDL3 might require some additional packages for like OpenGL drivers or Vulkan, that kind of thing. So we'll go ahead and hop into the Linux container, the Linux environment, try to configure the project and see where it fails, and that will let us know. VC package will let us know what's missing most of the time. All right, we're in our environment, so we wait for it to finish loading because the CMake tool hasn't popped up yet. There it is. So we'll hop over to the CMake tab. We'll hit configure, and it should start to download SDL3 dependencies for Linux, and then get them compiled. And this might take a little bit longer just because in the WSL environment running Windows, if you write or read from disk and you're doing so between WSL and Windows, it's a lot slower than if you were just writing or reading from disk inside the WSL environment. Otherwise, this would still be pretty quick. It's just how I personally have had this configured. Okay, so yeah, there it goes. So we're on package 1 of 17, 3 of 17. On Linux, it requires a few more dependencies than it did on Windows. Windows, we just had a couple of CMake dependencies because Microsoft gives you everything you need, whereas Linux, all of the tools are open source and are developed by individual maintainers. So you might get cursor events from one repo, windowing library from another repo, OpenGL graphics from another repo, and so this has to go out and pull them all in so that SDL can link against them and make them available for your project. Whereas Windows being proprietary gives it all to you. All right, this is going to take a minute, so I am going to go check on my cat who is hanging out in the garage and use the bathroom. I will be right back. I was muted, wasn't I? That's a rookie mistake. You know what? I'll just shut up. Rookie mistake. Oh, okay. This is what we were looking for. We knew that compiling was going to cause things to fail because the Linux environment wasn't set up with everything we needed. So this is our opportunity to fix that. So in the Docker file, let's see. It tried to build libxcrypt, which requires autoconf archive automake libtoolize, and it gives you the instructions to install them depending on which distribution you're using. And since we are using Ubuntu, which is a Debian distribution, we will grab this, copy it, and we will make this VC package dependencies. Run apt-get. Let's see. So it's going to give us a starting point here, and I'm going to do that. And this really isn't. Let's see. No install, recommend, remove appless. This really isn't VC package dependencies. This is, what was this? libxcrypt. So we could just say libxcrypt dependencies. And anytime we hit an issue, we'll just add more. So instead of rebuilding the container, I'm just going to manually install these as well. So we can do the same thing. Apt install, paste, hit enter. Ooh, we need to do an apt update first so that the container is aware of the latest repositories. And then we can run that again. There we go. Hit yes. All right. So once that's installed, we can try again. So we go back to CMake, hit configure, and let it do its thing. Normally I'd be playing music, but since I want to try and make this a video, I didn't want to risk getting audio in it, and I haven't figured out how to record audio separate from the video. I'm still new to all this. What I really need is to hire a video editor, a video producer, but I also need a following first, so that's going to take a minute. All right, I think we hit our next build error. So here we see libcryptx still failed. We don't necessarily know why, but we can take a look at the log outputs here. So there is a x64 Linux release error.log. And if we come in here, we'll see there was an error in this folder. Something went wrong bootstrapping make files. If GNU make was not used, consider rerunning it. So this immediately makes me think that maybe make isn't installed, because when we use Docker, and especially like a Docker image, we don't necessarily get everything that would come with a default desktop installation. So that usually means we have to install stuff ourselves. So here, for the compilers, we also need to make sure that make is installed, and then I can do the same thing in my terminal here. Apt install make. Cool. And then we will try again. Hit configure on CMake. See what happens. Can't tell. Would it be better to have a pretty graphic up while we're I don't have this set up to show a pretty graphic. Never mind. Don't worry about it. Never you mind. I was also thinking, I was reading about how other streamers figure out how to make videos and shorts and how to capture interesting moments. And I guess I need to find a way to like capture timestamps while I'm recording or streaming. So when I go back through the videos, I can more easily find talking points. Probably could have done that here, but I was hoping to not be on here too long. But the rate this is compiling, might be here all night. Also, my one Twitch viewer, I see you. The fact that you've been quiet this whole time, not said a thing. You're making me sound like a crazy person talking to myself. I don't know who you are, but for the past couple of streams, I've noticed there's been one person watching, and I can't tell if it's just a constant stream of someone accidentally clicking on my stream and then leaving, and then another person clicking on my stream and then leaving, and then another person clicking on my stream. Like, I don't know. But something's happening because I'm only averaging like 0.3 viewer per stream. So I don't know how any of this works. But if you're real, I see you. And I appreciate you. We're so close. Are we so close? Yeah, we're 2 of 9. Okay, we're getting there. Trust. We're getting there. Also, if you are you single viewer, if you're one of my friends or someone I know, I will find you. And we will talk. Because I know none of my friends have any interest in what I do for a living. I've seen their eyes glaze over too many times, even beginning to mention some of the stuff I do. I could almost hop into a game of Rocket League before this finishes, I think. I don't think this is stressing my computer, which was what I was trying to show earlier before I realized I was muted. Yeah, I'm only using 16 of 63 gigs. I hardly using any of my cores. You can see that my GPU video encoder is working because of the stream. That's kind of cool. I'm not really rendering any 3D graphics. What do streamers do when they're working on something and you're just kind of waiting? You just sit here and talk and chat. I'm slowly building up a I have a work office in my house. I use it for work during the day, but I am slowly turning it into a nice, more well lighted spot to do these live streams. Um, so we'll see. I've got a new mic coming in. I've got what else did I buy? I got keycaps coming in for my new keyboard. I'm really excited about that. What else? A microphone arm. It's an XLR mic, so I had to get a special doodad to connect that mic to my computer. I also think I want to use this as an excuse to buy a new computer, but I gotta really figure out how I want to do that because I think 64 gigs of RAM. How much is 64 gigs of RAM? Isn't it like $1,000,000? If I go to Amazon, 64 gigabytes of RAM. Oh my god. It's $2,000? What? What? What is this? Is this a laptop stick? $2,000 for 64 gigs of RAM? $1,000. Okay, okay. That's reasonable. Okay, we're getting down to $500. I mean, I have spent $400 on RAM before. So getting I'm assuming an off-brand. Oh, this is the wrong time to start streaming and wanting to get a new computer. Maybe I'll just stick to using this one. All right. Well, no. Okay, so maybe I don't need RAM. Maybe I can scavenge some RAM. So then, what else do I have? What else do I need? I need a GPU, right? What is like a low end GPU? GTX 5060 Ti? What? Wait a minute. How much is a 5070? I haven't looked at prices for GPUs in a long time, so I have no idea if that's even reasonable. What's the big one going for these days? Oh, oh. I mean, I have a 3090 Ti. I'm good. And I have a 2080 Ti that's sitting in another box I'm not really using, mainly because it's like it survived a power surge, and some of the ports on it don't work anymore, and then sometimes it crashes. But other than that, it still works. All right, so I think in a YouTube video, this section, do we fast forward through it really quick? Because I was thinking like 4x speed's probably good for a lot of this, but this seems more like 10x speed we need to get through. Or I just skip it all entirely. I don't know if anyone really cares to see this scroll by. thinking once this project is done, once I've got it working, probably going to do a little bit more of my game development. But I also kind of want to get back to my engine development. There's only so much time in a day, so I am kind of torn. We do have compile errors because of libsystemd. Looks like we need Python 3.13 env, so let's go ahead and get that installed. You need to install the Python 3 VNV package, so we will do that. I'll make sure the Docker file gets it. We'll do that, and then we'll also install it. Okay. Let's see. We will rerun CMake again. So we haven't even gotten to SDL yet, and once we hit that, we're going to start seeing all the different like libx11, Wayland, OpenGL, or libgl. We're going to see all those dependencies start to pop up as being required. We're getting there. I want to listen to music so bad. I'm also terrified of doing it incorrectly. I'm going to take a look at. Oh, someone said thanks. That's nice. You're welcome. So the guy that left a comment on my YouTube short asking how I got Pong running on Android, which led to me wanting to make this stream, I gave him a short explanation and said I might try and make a YouTube video, and he said thank you, which was really cool. It's actually really cool. Thank you goes a long way sometimes. I wish I knew how to find out more information about my streams. What is today? Today's the 23rd. I don't even know how to read this. Yeah, this makes no sense. I have 0.1 average viewers. I think. Yeah, 2 minutes watched. I've had a viewer watch 2 minutes of my stream. I'm thinking the viewer is a lie. And I have been talking to myself this whole time. So yeah, I really want to just get this recording done so I can make a YouTube video and call it a day. Not waste too much energy or effort on this. Because I've already done this. Dang it. a guy asked a question, and I felt inclined to help out in case someone else had a question. But maybe it wasn't worth my time. Maybe I should have worked on my game instead. I could have knocked out a couple of tickets, made a little bit more progress. We're just watching paint dry. I don't know if that's true. Do I have my dashboard open? I don't. Huh. Interesting. Oh, progress. All right, we're almost there. 3 of 4. One more to go. The last one will be SDL. With SDL, we'll be able to render graphics. Oh, God, I'm even bored of this. I need to go for a walk. Oh, it's only 43 outside. I wanted to go for a walk. It's a little cold. I mean, it's still doable. I guess I could still walk. It's not the end of the world. Do I do the streamer thing and go on like Wordle or whatever and try and solve Wordle real quick? Is that what streamers do? Guess I'll become a streamer. Wordle. I don't have an account though. Can I even play it? Okay. All right. Wordle. Let's see. Reach. Okay. ER. So let's do you. You. Your. You. 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 Young. Young. Let's do young. All right, we knocked out a bunch of letters there. So we have an R and an E with a bunch of letters left. So it could be like dread. Nope, can't be dread. Drew. Drude. Drews. Droon. Droom. Droom's not a word. Dree. Drip. 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 Dreep. Drip. Crepe. Crepe. Nope, can't be crate. Be free. No, we know this is an E. Fern Gully. Fern. Nope, why am I? Firm. Ferp. It's a ferp. Alright, I'm losing my mind. Alright. Losing my mind. Somebody stop me. D-E-T. Det. We need an R, don't we? We need an R, and it can't be the beginning letter. So, ear, E-A-R, fear. Can't use A. Pray, pewter. What are we thinking here? What are we thinking? Can't cheat. Don't want chat to give away the hint. Danger. For why do I want it? I want F there. I don't know why. Feet, fetch. Can't do fetch. Pet, Peter. I don't want to use two E's in case that's not it. If this word isn't it, I want to be able to eliminate more words. All right, so I need to eliminate more words then. So we got like film, films. Okay. F. I knew it. But we also have an I and an S. And we know F isn't the start. So now we're thinking like S-E. Doesn't start with an F. It could be E-I. Surf? Do we have an R? We have an R. Sir. How do you spell that? Sir. Is that right? That's not right. All right. Let me see where we're at. Oh, thank God. I think we're done. Oh, we're at the part where SDL needs all the X11, OpenGL dependencies, all that fun stuff. So we need to make sure that gets installed now. Run apt get. We'll do that. CL3 dependencies, and then we need to make sure we install libx11. What else? Wayland dependencies. In case we want to use Wayland instead. iBus dependencies, which I guess is the new way to do input handling for Wayland versus, I don't know. I don't know what it used to be for X11, unless it's just XKB common. Okay, so it's still configuring, so it's still thinking about it, but we know we're going to need those. All right, back to Wordle. So what are we dealing with here? We know something. What do we know? Surf. Is there a word that starts like this? Earps. Wait, do we have all 5 letters? 1, 2, 3. Oh, we have all 5 letters. What is this word? It's either an I or an S that begins. I'm guessing it's S. S-E. Seraph? Like an angel? Am I crazy? What is a seraph? Seraph? Typeface font. A slight projection finishing off a stroke of a letter in certain typefaces. Why did I think angel? Serif. That's what I was thinking of. I knew I wasn't crazy. Okay, cool. All right. Did I make did I gain any views from that? Let's see. Okay, so this is still configuring. So now how do I buy some more time to be entertaining? I can I can make a monster with my hand. Want to see this? Yep. No. You see? See? Oh, how am I going to explain this during a video recording? How am I going to explain this in a YouTube video? Yeah, I didn't think so. Are there lurkers in a chat like this? That would be crazy. Crazy, I say. I finally getting the screws in for my mount plate here. For my camera. So this is going to mount onto here. That's going to mount to a what do you call it? A monitor arm, and then I'll be able to drag the camera around to position it as I need. So then it won't just be like at an angle here. I might be able to get it on my beautiful face. We'll have to wait and see how that turns out. I don't have anything for lighting yet. I forgot to buy that, so that'll be coming at some point. I'm mostly excited for the mic I got. I got a pretty good mic on the way here. I'm currently using a Yeti, which I think has been okay. I think part of the problem is position to my mouth, and then the other part is probably figuring out the audio filtering to get a better sounding audio when I speak. Okay, let's see here. Oh, wait, did that compile? Wait, what? What? I mean, it compiled. We'll see if it runs. So if I compile, so all the dependencies are compiled. So now we compile our project. It compiled. So then let's try and run it. Now remember, I'm in a WSL Linux environment, but if this works, we can still get a graphics window with our Linux application. Nothing popped up, which makes me think that we do need to install these dependencies. So I'm going to go ahead and get these dependencies installed, which was what? I don't remember. SDL. So it's all of these. Yes. I'm honestly surprised SDL compiled without these, but it probably just means that it compiled, it's just not using any of them, which means we didn't get a window to pop up. Okay. So I'm curious if it'll recompile if I hit configure, or if I need to force it to recompile. Might have to force it to recompile. which is possible. Uh, yeah, it found X11 in Wayland, so maybe it's gonna recompile. Oh no, it's not. Okay. I don't know. Maybe we're still good. I'm gonna try one more time. I'm gonna build. I'm gonna run. Ooh, dang it. Okay. So I'm going to uninstall SDL3 by getting rid of it, hitting save. And then if I configure, this should remove it. All the following packages will be removed. Okay. And then I also have to delete it from the VC package cache so that it doesn't just install SDL3 from the cache again. It's going to fail to compile because we're actually looking for SDL3. So now I need to go find it in the cache, which, you know, in a workspace like this, I don't know where that actually is. It should be in the home directory. Yep, there it is. We'll remove VC package cache, which probably means I'm going to have to recompile everything again. I suck at this. Gosh darn it. Well, if someone is actually watching, I apologize. I have just wasted all of our time. So let's configure. I'm hoping it will still be able to pull from the build tree. So, like, stuff's already compiled. Oh, whoops. I need to turn SDL3 back on. Let's try that again. Configure. Looks like it's recompiling. I just gotta remember, I'm mainly doing this to record the video so that I can try and make my first YouTube video ever. I'm hoping I get enough B-roll that I can do a voiceover to kind of walk people through what all I did to get Pong up and running on Android. That's the goal. So I guess if I am going to do a voiceover, I could probably listen to some music and keep my sanity. I just don't know. I don't know how the professionals do it. And that's what I want. I like knowing how other people do it. How do I live without you? Forever and never. I guess another thing I could potentially do is work on. Yeah, this is going a little quicker actually, which makes sense because I have all the dependencies in container now. My eye's twitching. My eye will not stop twitching. Check this out. I've been working on some display cap or some scenes. So now I can go Full camera. Ah! To my desktop. Back to my camera. Now it's all manual clicking, but I can also do it for my vertical display. So I can do a vertical desktop, which doesn't really show much. I can do a vertical camera. Ah! Or just my normal vertical scene. Pretty cool, huh? Pretty cool. Ooh, I wonder. Okay, so I did want to try this. I wanted to see how audio sounded the closer it got. Time of the video is this? I got to remember this. This is 1 hour 52 minutes in, so I'm testing the audio, and I want to know if I sound louder, clearer, too loud. As it gets close, I definitely see it's probably louder. Is my voice getting lower and lower and lower and lower? Lower. All right, so this is me speaking at a normal volume with the mic a little closer. So I'm curious if using a mic closer to my mouth is a little easier to understand me and a little more clear. I haven't messed with any of the gain settings or anything like that, so I really don't know how that sounds. So then I got to remember all of this occurred around the 152 mark in the video. 152 mark. I guess I could write that down. Nah, I might remember. I might not. Maui was flooded? Maui was flooded. All right, so while we're waiting, I want to check that out. Maui was flooded. Can't do that here. I just look at images. Oh my gosh. Oh my gosh. Oh no. That sucks. That sucks. I wonder, could I have taken my other live stream recordings and done a how to for setting up a cross platform C project? Because if I make that a video, then this video could be more about what? I just wasted my entire evening. Could I have just used that video? I could have just been editing that video this entire time. Maybe I wasted my entire evening. But that's okay. It's a learning process. Got to figure this out somehow. I just really annoyed I had to recompile all this. I'd like to eventually learn to use some other editors, but I'd want to do that with a following to kind of goof off and try new things. I'm slowly getting a following on YouTube, kinda. I have 5 subscribers. That's more than I've ever achieved before. How do I have 5 subscribers, but I can only see one person? That's crazy. Do I need to make this? Oh no, did I screw up? Someone liked my video. I bet it was me. I bet I liked my video. I bet it was me. All right, where are we at? Where are we at? We're getting there. We're slowly getting there. Slowly but surely. No, I'm not very entertaining right now. I'm kind of tired. Tired and a little bit bored of watching this compilation happen for a second time. Because it wouldn't create a window, a graphics window for Pong. Which is kind of dumb. Kind of dumb. I have some other tickets I need to make sure I've gotten done. Okay. All right. I'm wondering if I just take what I've done before in the past and turn it into a voiceover video. Maybe I do that. Maybe I call this a wash. Because I recorded everything I did. Maybe this was a waste of time. This might have been a waste of time. All right. I think, in the interest of taking the path of least resistance to getting my name and company out there, I am going to end the stream for now and go try and work on the videos where I've already done this before, and then maybe just do a voiceover instead of relying on my voice recording from the video itself. Because that might make things a little more easy. So with that, streamer, if you truly are, or a streamer, viewer, if you were truly there this whole time, I cannot say enough how much I appreciate you watching. And if you are a bot or you are me who was watching, well then, well played.